So question one diagonal of a rhombus makes a angle of 29 degrees. So we just draw the rhombus now. So a rhombus looks like this. And what we know about a rhombus is that all sides are the same. So this side here are all equal to 7.2 inches. The rhombus makes an angle with one side of the one diagonal. Let's just draw this. And we know the diagonals intersect at right angles. So we know that one diagonal makes an angle of 29 degrees. And we know that this is 7.2 inches. And it says find the length of the diagonal. So all we've got to do is look at this right triangle here and find x and y using our sine and cos. Question 2. An observer on a cliff. There's the cliff. Here's the observer here. And the observer on the cliff, which is 50 feet high, 1,200 feet high, and spots two ships. So this is 1,200, and spots two ships down below. Here's the sea here. Let's put the sea in black, even though it's not black. And another ship over here. Angles of depression 48. So the angle of depression is always the angle that you look down to see something. So this will be an angle of depression going here, which is 33 degrees, which by the laws of parallel lines means that that is 33 degrees. The 48 degrees is the bigger one to here. That's 48, which means by the laws of parallel lines that must be 48 alternate interiors. So all we're going to do is use the big triangle, the little triangle. We've got one triangle that looks like this with 48 degrees. That's the smaller triangle, and this is 1,200. And we're going to find out x. And the other triangle is a bigger triangle like this, where that is 33 degrees. This is still 1,200. And we're going to work out y. And then the distance between the two ships, which is what we're trying to find, is this distance here, is going to equal y minus x when we come to it. Question 3 here. We're standing on a cliff, and the cliff is 50 feet up. This is the question with the 6 feet added on. So the person there's 6 feet, and of course the sea is down below. Oh, it's not a sea, is it? I don't know what it is. Anyway, we now have that this is 50 feet, the cliff bit, and this is 6 feet. And your line of sight now starts here. And you look down, you see two dogs. One at 51 degrees, angle of depression, and one at 37 degrees. And we talked about the angle of depression being this angle we turn through here. I've done this very well, of course. That's 37 degrees. So therefore, this angle will be 37 degrees. This angle here is the bigger one, which is going to be 51 degrees. And therefore, this is 51 degrees there. And again, same as we did the problem before, we're going to have two triangles. One triangle with small and one with the longer triangle. We know that this is 56 here because we've got the 50 added onto the 6. And we're going to try and find x and y, and we know both of these angles are 37 and 51. Question down here. So the tree casts a shadow. So there's the tree. There's the tree there. Let's put some leaves on it. So we can get some green in there as well, perhaps. So there's our tree. And this casts a shadow on the ground from the sun. Let's just do the sun coming down here. and the sun's rays would come down, and of course the shadow is going to be this bit here. Okay, so let's go back and see what the question says now. A 40-foot tree, so we know the tree is 40 feet, casts a shadow of length 60 feet. And it says, what angle is the angle of elevation? Well, this is the angle of elevation here. Angle of elevation. You can see enough, the angle of elevation always equals the angle of depression going the other way, and we'll just prove that. So the angle of depression would be this angle here. So angle of elevation equals the angle of depression, so we've got to find theta, and we're going to use tan to find it. Easy question, find tan. So question C, talks about the rectangle, and 100 by 50. And we've got to look at finding the angle of where the two diagonals intersect. It's got to be the acute angle, so it's going to be either of these. But we do know that if we draw a triangle across here, a line across there, that's a right triangle, this would be 50, half the length of that, and this would be 25, half the length of that, and therefore we can work out this angle here by tan. And then this one here would be the same, and we double it to get the final answer, which is this angle, the acute angle between the two diagonals. Question E. And we got the marksman who is 60 meters away from his target here. Just put the target here like that. He's trying to get in the middle, obviously. Here's the gun and his eye line. Now the question says if his eye line moves 1/4 of a degree, so this here is 1/4, which equals 0.25 degrees, and you've got to find this length here, given that this is a right triangle. And again, we're going to use tan, just call that x. So tan of 0.25 degrees equals x over 60. Now it says that this is meters, so your answer will be meters, but it does say find how many centimeters, so you have to change that back. Question I talks about a gabled roof. There's your roof there. You know the height, which comes down the middle, is going to be 2.1 meters, and the distance across the bottom here is given as 10.9 meters. So if you split 10.9 in half, you'll get this distance here, and then we're looking for this angle theta for the answer. Question P talks about the UFO being sighted from below with a spotlight, and then from 2 kilometers away. So that distance there is 2 kilometers. And we know that the first spotlight is 15 degrees to the vertical. So by parallel lines, that is also 15 degrees, and we're trying to find out x, the height of the flying saucer. Question R talks about the xy axis. The point 615 is about there, and that line is a line drawn to the origin. The origin is the point 0, 0. A smiley face there to make it look funny, but that's not part of it. No, can't do that. No humour here. So drop this perpendicular line down, vertical line, and we form the triangle here. We know this must be 6 along the x, that must be 15 along the y, and we're trying to find the angle made with the x-axis, so theta there, and of course we use tan. Question T talks about an octagon inside a circle. It's not going to be easy to draw, but we'll try. 1, 2, 3, 4, 5, 6, 7, 8 sides, and each side is connected to the middle by the radius, like that. 360 degrees all the way around, so each angle here must be 45 degrees. That's 360 divided by 8. So we look at that triangle there, the one we've just put the 45 in, and we drop this perpendicular to the middle. This angle here will be 22.5 degrees. The question says that the regular octagon is sides 10 meters, so these are going to be 10, so it's going to be 5 here and 5 here. And it says find the radius. Well, the radius is here. This would be a radius here. Put in a different color. This would be a radius. Of course, therefore, on my triangle, this is the radius R. And we know we can use, I think that looks like sine to me. U, another good question. Here's the swing with the seat, and the motion of a swing is circular, so the swing will end up here somewhere. And the question says it makes an angle of 41 degrees. Well, the swing has a length of 400 centimeters, and there's also a distance here above the ground of 50. Now, at 41 degrees, you're asked to find how high the swing is above the ground. That's the question. How far above the ground is her seat now? So all we've got to do is draw a triangle across here. So we form a right angle. We know that this is 400 because the swing, the length of the rope will not change length. And we're going to try and find out this length here on the triangle, which we'll call x. And we can use cosine, I think. Cos 41 equals x over 400. Once we find x, h is going to be 450, which is 400 plus the 50 minus the x.